Okay, so first of all, let's talk about signal. So as I told you, so first of all, let's see, okay, when we use signal and what is the usage of signal. Basically, as I told you, signal is a one type of IPC, inter-process communication. So if you need to communicate with your process, so you can use signal, but in a sense, basically signal is a type of asynchronous communication. So asynchronous communication, it means that, okay, your process is just executing and is doing its stuff, but at the middle of execution, basically it's possible that it receives a signal and it goes and basically try to handle the signal. So it is a kind of asynchronous communication, but it's possible based on the flexibility of the implementation. So we can have basically synchronous communication based on the signal. So apart from the communication with the process, so we can use signal in order to basically signal handler in order to avoid inconsistency in your program. So when operating system creates basically the process, so already we have some default action for the signals. So actually maybe at the middle of the execution of one process, so maybe you receive some signal, it's just like a signal for terminating the process, and so if you don't handle the signal for termination or maybe for interrupt, so at the middle of execution you should basically drop your execution. You should stop your execution, and this is not basically is not a good point, because maybe you have some memory allocation during your execution, and so if you suddenly basically stop the execution, so basically you have some memory leakages. So in order to avoid that, maybe you can install some signal and try to handle by yourself basically the signals. And so it basically you try to avoid inconsistency in your program. But another thing is that is important for the signal that you should know, because maybe you see that, okay, when we use signal, so by sending maybe some notification, so we can handle basically some synchronization mechanism. So synchronization mechanism, it means that if you have some processes or some threads and you need to have some execution order in your program, so maybe you need to have a synchronization. Or maybe, for example, you have some shared variable between the threads or between the processes, you are going to orchestrating the accessing to this shared variable, so you need a kind of synchronization mechanism. So you can basically manage to implement those synchronization mechanism through the signals. And so because signal, first of all, the point is that it is not a very safe point to use the signal for managing the synchronization, because first of all there is a gap between the generating the signal and also receiving signal from the other part. So it is not a safe basically method in order to implement the synchronization. But we have some synchronization mechanism that it is basically used the signal in their implementation. But according to the implementation, so basically we have two types of implementation. First of all, we can use signal, or we can use also sig action. Okay, so this is basically this is the notation for the signal implementation. So maybe the appearance of the function is a little bit scary, but so you can consider it very simply. So you need to pass as a first argument of the signal function. You need to pass. Okay, so you are going to deal with which signal? Okay, so first argument you are indicating that, okay, you are going to dealing with which signal. As a second basically argument, you are going to indicate that, okay, so if I receive this signal, okay, so which is the handler or which is the catching function, also it is called. So catching function or handler, they are synonym. So which function you are going to assign for handling this basically this signal. And this is the whole thing for a signal. And we have also another implementation for a signal. This is called basically sig action. So sig action, okay, so you need to pass basically three parameters to sig action. First of all, you need to indicate that, okay, you are going to deal with which signal, okay, and after that, basically you need to pass one act and also one AO act. So A act, it basically is a kind of disposition. So these two parameters, the first parameter and also second parameter here, they are the dispositions. But if I want to give you the imagine of the disposition, what is that? So you can consider it as an object. Okay. So you can consider it as an object that if I receive a signal that we indicated here, okay. So how you are going to deal basically with that signal? So you need to prepare an object, and so this object is basically you can define it inside of the struct sig action. So I put it here. So disposition is basically equal to the struct sig action. So but what is inside of this struct? So you need to indicate basically the handler. So here you should see that if I receive this signal, how can you basically handle the signal? So you need to indicate it here, and after that you need to indicate basically the mask for the signal. So the mask for a signal, it means that you can specify some a list of signals in order to avoid the problem. For example, when you are going to handle one signal, so you decide to not dealing with another type of signal. So you can basically add those signals inside of your mask. And
so basically you cover those signals.
You try to cover those signals. What is your behavior for those signals when you are basically dealing with another type of signal? And also with the SA flags, so you can basically modify the behavior of the signals. Okay, but I give you the one example. I suppose that in the example, so all of this stuff should be clear. But the point is that I give you some hints regarding to these two type of signals. Is that unlike signal, so sig action is much more flexible in POSIX environment. Okay, so if you need to basically write the code that is more portable, so it is better that so you use sig action instead of signal. And another thing is that sig action, it gives you much more flexibility comparing to the signal. So maybe using signal is much more easier comparing to the sig action, but basically sig action it gives you much more functions, and you can play a lot with the signal. So it gives you much more flexibility. But another thing is that so we have two implementations, signal and sig action. But anyhow, so we can use both of them at the same time in one program, but it's not basically recommended. So we can use signal and sig action in the same program. But I want to recall one thing from the last sessions. So if you remember, we talked about files. I will introduce you two approaches in order to handle with files. So file stream and also file descriptor, right? So also there you can use both of them in one program. So you can use file star and also file descript, both of them in the same file. Because also there we have some functions in order to, for example, when you open up a file with the stream, so we have some functions in order to get descriptor from the stream, and then you use another type of functions. So also here, when you have signal and sig action, so you can use both of them at the same time in one program. But here I list some standard signals for you. For example, we have sig int in order to interrupting a program, and basically sig int is equal to when you press Ctrl C. So it is when you press Ctrl C, basically you are sending sig int to your program. Another thing is basically sig term in order to terminate your program. Okay. And also for each signal we have one value that is basically assigned to the signal. So we can have, for example, we can use number 2 for sig int. So it doesn't matter that I work with the number or I work with basically the name of the signal. So I made a mistake here. This is not 1. It should be 15. Okay. Sig term is 15. Is not 1. Sig hop is 1. So sorry, I made a mistake. And sig kill. Okay, so this is the value is 9. And so if you are going to kill immediately one process, so you can use sig kill or maybe sig alarm in order to generate an alarm for handle the alarm basically signal, or sig child. So when the child process basically terminates, it basically sends the sig child to the parent. Okay, so this is a signal there. And also we can have some user defined signal. For example, SIG-US R1 or maybe SIG-US R1 or SIG-US R2. So these are some signals that you can basically, it is not the predefined basically handler, or it is something that, okay, so you can handle it by yourself in your program. But for the action, okay, so when we receive these type of signals, for example, the sum of them, okay, it's much more than this list, but I just basically picked up some of them here. So we can basically have 3 actions when I receive one of these signals. So I can basically use SIG-DFL. SIG-DFL, it means that, okay, I want to have the default behavior for this signal. Or maybe you can use SIG-IGN. So it means that, okay, if I receive this signal, I'm going to ignore. So it means that I don't receive anything. Or maybe you are going to modify the behavior of the default behavior for basically for the signal. So in this way, you need to introduce one handler by yourself. So this is the 3 actions that you can do by basically in your program. Okay. So is that clear? Okay. So now, let me I give you some examples regarding to these issues.